and you should be able to see my sheet, which has all of these letters, which are the bases in DNA going across here. So the first thing I need to do is I need to split them up because they don't make sense like this. This is nonsense. So I need to split them up into how many?
3.
Groups of 3. Beautiful. So I'm going to do that first of all. Okay, so I've just put a line through between each little group of 3. So I've got an ATA, an ATA, a TTG, a TTA, a CAG, and so on all the way along. So that's the first thing that we do. And that's important because the way that we read this code, we need to make sure that we have groups of 3. They're called triplets. And we're going to produce in our messenger RNA codons. And the codons are what's going to be really important. Now, what do I have to remember when I'm doing this? What's the important rule when I'm creating messenger RNA from DNA? So here's my first one, ATA. What do I have to remember over here? What do A's go with?
T's.
They go with T's. Now, here's one small change. A's go with T's and G's go with C's. But in RNA, there is no T. Instead, it's a
U.
Beautiful. Which means where we would put a T, we put a U, which means the first one is going to be U, A, U, and then U, A, U again, and then A, C, A, U, G, U, C, G, A, G, G, A, G, C, C, A, U, A, G, G, A, G, G, C, C, and C, A, C. So what I've done is I've gone all the way along and I've transcribed my DNA message into a piece of RNA. Now, the piece of RNA, I'll leave that up there for a second. So the piece of RNA is a single strand and it has all of those letters on, but it's got the letters grouped into 3s, which just makes it easier when it gets out of the nucleus into the ribosome so that it can then be translated. So that's the second step. So the first step is transcription, transcribe the message, write the message out, and then translate the message. The translation step is about making sure that we know which amino acid goes where. Now, I've given you sheets which have these on them. Okay? So we have to work out what's going to go with each of these. Now, here's the problem. From our messenger RNA, we have to link a transfer RNA, which has an amino acid. Okay? So I'm going to go from my DNA to my messenger RNA to my transfer RNA and an amino acid. So in order to do that, I need to try and work out what my sequence is going to be. So the first messenger RNA I have is UAU. So I'm actually having a look through here and I can't see UAU. And that's because I haven't translated it yet. So how do I translate that message, UAU? What will it actually be? U's go with?
T. G?
U's are the T, so what do the T's go with?
Or A.
Correct. So this one is actually AUA. Okay? So when I translate that, I actually get AUA. And here is one. AUA. So what I'm going to do is I'm going to very quickly cut that out with my pair of scissors, which you can do yourself if you have printed this out. If you haven't, that's okay. You can either draw these or you can stick them in, whatever you want to do. Got a little bit of glue as well. Hopefully there's a bit of sticky left in my glue. And pop that on there and stick it there. Beautiful. So now it looks like this.
What is it?
So here's my ATA, that was my DNA. Then there was my UAU, that was my messenger RNA, which had the complementary bases, A's with T's or U's and G's with C's. And then I come back to transfer RNA. So my transfer RNA shows me which little amino acid, which one of these little shapes goes there. So then I'm going to look at the next one. Okay, the next one is the same. And that's coming from the original message that was in the DNA. So you see, we do the complement, we switch it over to form the messenger RNA, and then we switch it again. So it kind of goes back to the original. So it would look like the original up here. In fact, if I do the next one, you'll probably see it's much easier because the U's and the T's get a bit confusing. So you can see the relationship between the piece of DNA here, CAG, and then my transcription, GUC, and then my translation, CAG, CAG. You can see this is the same as what was in the DNA. And in fact, all of these are the same as what's in the DNA. It's just we've replaced the T's with a U because we don't have a T in RNA. We only have a T in DNA. And that's why the sequence builds up like this. And that's how we know. So these would all be different amino acids. Now, how do we know when to stop? Yeah, because there's a stop code, isn't there? There's a couple of stop codes. So when we get to something that actually tells us to stop, we stop. So you're going to keep building up this section of a protein. So these are all, what these would all be is amino acids, and they're different amino acids. So they have a slightly different chemical nature. They don't have different, they don't look like this, but they can have different shapes because the way that they bond together changes depending on what's part of this little system here. So this is a nice little cut and paste exercise for you. If you are able to do that, it's probably a good idea to see if you can finish it all the way along. Mine's going to get a bit squished, I think, by the time I get to the end, but I will finish that for you and I'll give you a look at that tomorrow. Here's the little challenge.